The second one returns John, who is apparently an admin. Hello everyone, and welcome to this video in which we're going to solve the hard challenge while training. Let's get started. This challenge is part of the CTFchallenge.com website, which is developed and maintained by Adam, and I've already covered it in a previous video. Okay, so let's click on the challenge. You'll see that I already found 10 out of 11 flags. Let's see if I can find the 11th flag with you. Let's begin the challenge. Let's proxy our requests through burp, and it seems that it's only a static page. So the first thing we need to do is perform subdomain enumeration. And to do that, I'm going to use DNS recon as in the previous videos. I'm going to choose the domain voltraining.co.uk with the word list names.txt and with the type brute force. Actually, I think it's not names but subdomains. So what I can do is update the list of word lists from ctfchallenge.com. So if we go to the home page, challenges, you have a page here, word lists, and here you can find the list of all the word lists. To do better, there is a onboarding process next to the word lists link. And here when we click on next, we have a list of all the commands that we can run at once. So copy this and paste it here. So I have some duplicate files. So what I can do is remove all the txt files and redo the same command as before. All right, now we have all the word lists. We can go back to our voltraining folder and repeat the DNS recon command. This time we're going to use the subdomains word list and hit OK. After a couple of minutes, we have admin, billing, and www, which all resolve to the same IP address. So let's take this and put it in our notes. You can use Notion or any other tool. I'm using here Sublime. So the first approach to subdomain enumeration is brute force. The second approach is certificate transparency, and there are many tools that do that. I prefer using Asset Finder from TomNomNom's GitHub repository. So let's use it. It seems that I have to install it once again. I think I need to remove the HTTPS prefix. And now I can run Asset Finder with the option subdomains only, and then our domain. And straight away, we have the same subdomains as before. We don't have admin, on the contrary. However, we have a new subdomain here. So let's copy this and paste it in our notes. We can write passive enumeration. So that's all for our subdomain enumeration. Next, we are going to do directory brute forcing. And we're going to use these as inputs. But before that, we need to find out what's behind those subdomains because they can host services other than web servers. So we can use Nmap for that. To be gentle on Adam's servers, I'm just going to use the top 100 TCP ports. So I use the top ports option, and then I can supply a list of my assets. And I'm only interested in open ports, and I would like to use the verbose mode. Of course, I don't have the file assets, so let's create it. And here we can paste our subdomains. Actually, since they all resolve to the same IP address, I can perform only one scan. So actually, I don't need the input list. What I'm only after is the IP address. We find that SSH and 80 are open. So let's start with the web server on port 80. First, I'm going to target this gibberish subdomain. So if I open a new tab, and straight away we have a flag. We have the first flag for this subdomain on the root folder. Let's see if there are any other folders under the same subdomain. And to do that, I'm going to use -u for URL. We are interested in this subdomain. And we want to use the word list, which is called content for content discovery. And we want to fuzz the first level directory. It run fast, and you notice that we have only those matches. However, I already know that there is some sort of rate limiting. So what I can do here is match all the requests, all the response codes. And here you can see that there is a repetitive 429 status code, which means too many requests. So we can tamper with this by reducing the number of threads to 1 and the rate to maybe 5. And now we have somewhat better results. So I'm not sure what this 418 code means. So I'm going to exit, try to test with one of them, and it's returning the same flag. And so what we can do here is filter out the responses based on their size, which here in this case 662, and it will take some time to find subdomains. So we're trying to bypass the rate limiting here. So I've already done this exercise and didn't find anything on that subdomain. We can do the same for the others, www. And here we have the same 662 size response. So what we can do here is filter by this size as well. And I've already done this exercise because I don't want to waste time waiting for the directory brute force to finish. What I found is the robots file and server directory. So if we go to /robots, we can see that there is a secret directory which returns another flag. The server endpoint, however, gives access to server status page with a logging feature. So if we try something like admin, we have invalid username and password combination. So one thing to maybe try is to brute force those. But since we don't have a username enumeration disclosure, it would be very hard to try to guess both the username and the password. So when we inspect the post request, or actually when we go to the /server, we can notice there's a 302 redirect response code, which is redirecting to /logging, right? A common flaw is fail open, which means that the application discloses information on the process of doing something. Like in this case, redirections should not normally return a lot of HTML code, but in this case it does. So if we render the page, you can see that it's returning a totally different page here, prior to redirecting to the logging feature. So for us, it's important because we land on a third flag and we have another link, which is PHP my secret admin. So let's go to this page and we land on a PHP my admin. So it seems that there's a database behind and we need to authenticate to it. Let's put this in our notes. I'm not going to perform any brute force on those login screens. I'm going to continue my enumeration for the other assets. Another endpoint that I found is .git, which returns a forbidden error, meaning that we can't list the content of the .git directory, which is typical for Git repositories. So the developers have pushed the entire folder of their website without removing the .git, which contains all the information about the versions of their website. So a typical file is .git/config, and if we go to burp, we can see straight away that it contains a reference to a GitHub repository. So if we visit that page, it's a framework used by a vol training firm, and in the About section, we have another flag. So those were found under git config. And let's see what's inside this framework. It seems that it's a typical MVC framework with models, views, and controllers. And we have the routes folder, which can disclose URLs to the framework. In this case, we only have the route to the root folder. However, if we go back to the repository, we notice that there are 3 commits. The first one is first commit, which only creates a README file. The other one seems like the first upload of the framework. And the third one is interesting. We have removed database credentials now that we're making this project open source. And straight away, you can see that there is a difference between the new version and the previous version. And it seems that we have a database connection string here, MySQL with the host, localhost, the port 3306, which is typical for MySQL, the database name, the username, and the password. So if you remember, we had a login page on phpMyAdmin. So I wonder if the developers or sysops have changed the password of their database after pushing the update of this repository by removing their credentials. So let's try that. And it seems that we've been able to log in. So let's document this. Once inside the database, we have billing users with a flag. And there is a somewhat long password, which seems like a base64 encoded with the 3 dots at the end. We can't really use that password, can we? But first, let's see where we can use this username Dominic.Bryant. From the name of the table, billing users, we can test it on the billing subdomain. And sure enough, we land on a logging screen. And let's try this username. Let's use admin as a password just to test. And we get password is invalid, meaning that the username is correct. So if I use like admin with the password admin, I get username is invalid, which means that this is an information disclosure that allows us to double check that indeed Dominic.Bryant is a valid user. So what we can do here is maybe try to brute force the password. So let's send a request to burp. Here it is. Let's send it to the repeater and target the let's send it to the intruder and target the password. We're going to load the passwords from our word list. Go to the challenges section, word lists, passwords, then copy this file and paste it right here. And here, to avoid the rate limiting, we can create a new resource pool. Let's name it slow with maximum concurrent requests 5, and let's choose a delay of 300 milliseconds with a random variation. In the options, I'd like to filter based on the response. So I'm going to choose grep extract element, click on fetch response, and select password is invalid. This would tell burp to differentiate between the responses. I'm going to start the attack. And as you can see, a lot of requests here return password is invalid. If I sort by this response, we see that there is a 302 redirection, typical of a successful authentication with the password from 9 to 1. So let's grab this password and try to reuse it. The username is Dominic Bryant. And sure enough, we land on the billing application with a flag here. So let's document this. All right, it seems that we have access to some invoices which are all paid, and when we choose one of them, we get information about the customer and the product, etc. It seems that we don't have any SQL injection. We can start enumerating the parameters because they might be something hidden. So let's send this to the intruder once again. And here I'm going to target the get parameter part with something random. For the payloads, I'm going to use the list of parameter word list from ctfchallenge.com. I'm going to copy the content and paste it here and choose the slow resource pool and then hit start. We can filter based on the length of the requests. It seems that we have an outlier here with a considerably low response size, and in the response we have API error. That's interesting. So let's send this to the repeater and try to play with it to understand how it works. So maybe that's a path to an endpoint, or maybe a path to a server. We still have the same response, so there might be a blind thing going on here. So what we can do is to point it to a server that we control, and Burp provides us with the collaborator server. And here we can copy our host name and paste it here, then send. And hopefully the backend server will take this API parameter value and use it to fetch some resource. If we poll, we indeed receive an HTTP request with a token and flag. So let's copy those and paste them in our notes. So it's an SSRF vulnerability with the API parameter. I'm already familiar with Adam's thinking. So whenever I see X token, I know that there's a header that should be added somewhere. So let's copy this token and see where we can use it. So far, we have tested www, billing, and this random subdomain, but we haven't tested admin yet. We get unauthorized. Now, what happens if we add HTTP header? So this is our admin request. Let's send it to the repeater and verify that we are unauthorized. But now let's add our header. And as you can see, we indeed have access to the admin subdomain, and we have an endpoint called invoices. So let's go to that endpoint, and we have the same content as we had in the billing subdomain, a list of all the invoices from 1 to 4. So if we target the first invoice, what should we have? You guessed it right, we have the first one, and the second one would return the second invoice. Now what happens if I subtract 1 from here? I get resource not found. Doesn't seem like a SQL injection either. So let's try directory enumeration on this subdomain to see if there are any other endpoints not listed here. Like before, we're going to use FUF. This time we're going to target what happens to this display. We are going to target the admin subdomain, but I'm also going to add the header. But you know what? I can use Burp to do that, which is better. That way I don't have to add any cookies or headers manually. So I'm going to just send this to the intruder, clear everything, and target the root directory. And then I'm going to paste in the list of directories. So that's our content file here. Copy it and paste it right here. Choose the slow resource pool and start the attack. I cheated here. I used another word list just to save time. But as you can see, I have a 403 here for the /admin endpoint. And here it says user does not have permission. Okay, that's interesting. So what happens if we try to brute force directories under this folder? There might be insufficient access control on the subfolders. So what we can do is retry our same attack, but in this case, I'm going to brute force what's under the admin directory. I'm going to cheat once again, and I already know that it's something like user or users. So if I start the attack, when I sort by the response code, I get /users as a hit with the same error. User does not have permissions. Okay, so this means that users is a valid endpoint. So what happens if I do admin users and then I try a random integer? Let's target the first user. Oh, so we get user not found, which means that there is no proper access control maybe on that deeper subfolder or endpoint. So let's try with user 2, same thing. Let's send it to the intruder and clear everything and target the integer. I'm going to use the numbers payload from 3 to maybe 15 with a step of 1. We don't want any fractions, and we want the slow resource pool. Let's start the attack and sort by the status code. So right away we see that we have 2 users, 3 and 5. The first one returns the current user, Dominic Bryant, with an API key. The second one returns John, who is apparently an admin. So let's take this response and put it in our notes. So this is our flag, And this is our API key, so let's copy it and use it in the repeater instead of this one. It seems that it's working. Now if I try to list all the users, I do have access. So this means that John is indeed an administrator. Okay, so let's go to the root directory and see that we have the same endpoint invoices. If we go to /admin, oh, so we have like administrative endpoints. We have /users, which we've already seen, and secret messages. Let's copy this and paste it here. And indeed, it seems that we have an element with ID 2. So let's try to access that message. Okay, so we have, hey, did you get my other message? What message? Maybe we can change the ID. Let's try ID 1. Oh, bummer. Message is deleted. Okay. Do we have any SQL injection lead here? 2 minus 0. It seems that it worked. So this is a lead for a SQL injection, right? But how can we leverage this? So we can use this to exfiltrate data from the database by comparing the response and inferring the content of the message. In other words, if I enter 2 and 1 equals 1, I'm going to URL encode it using Control U. As you can see, I have the result of the second message, but if I do 1 equals 2 here, I get message not found. Based on this comparison, I can try to exfiltrate the content of the first message. To make it clear here, if I go back to my second message, you can see that the message here starts with H. So if I do here 2 and substring, which is function in SQL, to extract the first character with an offset of 1 from the message column. Let's test and see if it's equals to H. I'm going to encode this and send it. I made typo here. Actually, it's the name of the attribute and then the substring. Sure enough, we get the result, but if I change this to O, I get message not found. So using this, I can try to access the content of the first message by just iterating through the different offsets of the message and comparing them to a char set. In this case, I would use A to Z and then 0 to 1. Okay? So I can start with 1 and walk up to Z. So let's send this to the intruder and clear everything. We want to target this part right here. And I'm going to use a simple list from 1 to Z. And let's use the slow resource pool and start our attack. So there is a difference in the content length of the response here, which says message is deleted, which is different from the other messages, message not found. So this means that D is the first letter of our first message. Now we can do this manually, but I don't want to waste my time. So I created a script for that. So as you can see here, I'm defining my URL to be the admin subdomain, with the endpoint being my path to the secret messages. And as you can see here, we have the payload 1 and substring message. I'm iterating through the offset of the message and taking only one letter, and I'm comparing it to my char set. And then I'm appending a comment to finish my SQL query. I'm using the cookies for my account, and I'm using the header X token for the admin user, and I'm defining a char set that's comprised of letters, lowercase letters, and digits. Then I'm defining a new variable with message that's going to hold my final flag, and then we are going to iterate through the length of my message. Now, how I did find this, let me show you. There is a function called length in SQL, which returns the length of an attribute or a column. So in this case, I'm targeting the message column. If I send this, I get message not found. However, if I do 84, I get message is deleted. And this means that the value of the length of the message is 84. Now we can start from scratch and test if the length is bigger than 100, which is not the case. So we know that it's less than 100. So maybe it's bigger than 50. And that way we divide and concur. So in this case, we know that it's bigger than 50. We walk our way through that until we find the exact length of the message. So we iterate through the length of the message, and for each position, we iterate through our char set, and then we just substitute this string, inject our cookies on our headers, and we try to avoid rate limiting by sleeping for half a second. Then if we have message is deleted in the response, we know that the comparison is true, and so we append that to the message and we just print that message, and then break out of this loop and target the next position. And finally, we print the message. I'm just going to port this to Python 3. I need to install the requests module. So it seems that the new name of the lowercase char set for the string in Python 3 is ASCII_lowercase. I've developed this in another box with Python 2, so let's just add ASCII here. And while we're at it, I can also add opening brackets, closing bracket, and this symbol to cover the structure of the flag. So let's run this. So let's give it some time to exfiltrate the content of the hidden message. What a huge message. Don't share this message with anyone with our flag. All right, I think we've covered the entire application. We were able to access the administration page and exfiltrate a hidden message. I'm not sure how many flags do we have now. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. We still have 2 left. For me, my objective here is to gain admin access and exfiltrate sensitive data. I'm satisfied with the dopamine level I already have. However, let's see if we can find the remaining 2. So whenever you hit a wall, you go back to enumeration. Let's go back to our www subdomain. So we had a empty or static page. If I inspect the code, I don't see anything interesting here. Maybe in the head. Oh, okay, so we have a new flag here. I just failed to see the source code of the main web page. So let's put it right here. What about the second one? Let's continue our enumeration here. Maybe look for any URLs. So we have on training, we have home. If we go to the style, we have a background image which points to an S3 bucket. If we go there, I wonder if directory listing is enabled. Request the root of this S3 bucket. I can see a listing of the entries or the keys in this case. So here we have heading.jpg key and we have a flag.txt. Okay, so if we go to flag.txt, we indeed find the last flag. Oh, right. So there you have it. A full walkthrough of this seemingly hard challenge, but to be honest, I found that the Vuln form challenge was way more fun than this one, but I really enjoyed exploiting the SSRF and the SQL injection. If you found this content helpful, make sure to like, comment, and subscribe to this channel so that you get updates whenever I publish a new video on ethical hacking and bug bounty hunting. If you're new to hacking and want to learn the basics, check out the free OWASP Top 10 theory and hands-on training on thehackerish.com and apply your knowledge on the lab which supports it. If you enjoy learning with videos, I invite you to watch the OWASP Top 10 YouTube playlist. However, I encourage you to first try to solve the lab exercises so that you don't spoil them. Don't forget that there are supporting blog posts for most of the videos you watch on this YouTube channel. I also encourage you to subscribe to the Friday newsletter on thehackerish.com to gain some new hacking knowledge at the end of the week. If you enjoy listening while doing other things at the same time, check out the Hack for Fun and Profit podcast, link in the description box. Until next time, stay curious, keep learning, and go find some bugs.